Hello everyone, welcome back to your favorite and India's most affordable learning platform, Physics Wallah. So in the last session of laws of motion, we discussed the Newton's third law and the rocket propulsion, right? So, and we have solved some numericals related to the rocket propulsion and the Newton's third law. And we also covered the basics of the conservation of linear momentum. So where the advanced questions of conservation of momentum will discuss it in collision chapter. Okay, so in continuation of the laws of motion, in the next lecture, that is lecture number 7, so where we are going to start the friction concept today. Okay, so friction concept, most of the students, they get confused in this. So all your doubts and will be clear in these 2 to 3 sessions. So today, tomorrow and day after. So these 3 sessions I am going to cover the complete friction chapter. Okay, so like all the questions related to friction I'll solve and I'll make you understand. Okay, just you have to believe in me and yourself. All right, chalo. So our today's targets are friction, static friction and kinetic friction. What is friction first, and then these two are the types of frictions. So the static friction and the kinetic friction. Done. So let's start. Before starting, so as usual, avoid all the disturbances around you for the next 1 hour, and at the end of the lesson it's very important to write your own short notes. Clear guys? Chal. So let's start with the today's session. So first, what is friction? What is friction? Tell me. Friction is nothing but friction is which opposes the relative motion. That's it. So it's a friction is a contact force. We have seen in the starting of the Newton's laws of motion, first class. So friction is a contact force and it always opposes the relative motion between the two bodies or tendency of relative motion. So for example, see, this is a rough surface. The friction always acts on the rough surface, right? So for rough surfaces, if the surface is smooth, in the question, if the surface is smooth, so then there is no need to consider the friction. Okay, so till now whatever the questions that we have solved, they are related to the smooth surface. There is no friction concept. So now the friction comes into the role. See here, so it always opposes the relative motion of the body. See here, so this is a block of mass m. Let's suppose the block is moving to the right. We are applying some force F, so the block moves to the right. So as the surface is rough, so shall I say that the friction opposes the relative motion? So the friction acts in this direction. So the friction acts in this direction. So here the body is actually moving, or else, so here consider an object is placed on the inclined plane. So this is a object is placed on the inclined plane. So now this object is not actually moving, but it's tending to move. So the tendency of relative motion. So the tendency to move, the object may move this side, so that the friction will act this side. If the object is actually moving, so then it opposes the relative motion. So if the object tends to move, it's not moving, it tends to move, so then also the friction opposes the tendency of that motion, a relative motion. Clear? This is a basic thing, right? So let's move further. So on what factors the friction will depend? So on what fractions frictional force between the two bodies depends? So first, the nature of surfaces in contact. See here, so here let's suppose this is a surface, rough surface, and this is a block of mass m. So here the nature of surfaces in contact, which is actually measured by the coefficient of friction. This is a mu is a coefficient of friction. Mu is a coefficient of friction. See here, so between, if the surface changes, the mu value changes. So for this surface, see here, for this surface and the block, so the coefficient of friction, let it be mu1. So if I take some other rough surface, okay, and a block of mass m2 is placed here now, So consider now, this is a coefficient of friction between these two surfaces is mu2 now. Okay, so this coefficient of friction, it tells us the roughness, how rough is the surface. It talks about the roughness of the surface. So if the mu is more, then we can say the friction is more. Yes or no? If the coefficient of friction is more, the surface is very rough. Okay, and the friction is more. Yes or no? If the surface is very the surface is highly roughed, so then what happens? The friction acts more. Okay, so understanding, if the mu value is more, so then the roughness is more, so then the friction acts more. That's it. This is the concept you should understand. Then basic thing, this is the first one. And then so the friction also, the frictional force also depends on the normal reaction. See here, this is a rough surface. So here we place the object of mass m. So now here the normal reaction also comes, because whenever there is a contact force, the friction is the contact force, right? So here is the contact. So whenever there is a contact force, so the friction will come into the role. Sorry, yes or no? So the normal will come into the role. So here normal n, here it is equals to mg. So in this particular case, so the normal is equals to mg. But don't say that normal is equals to mg in all the cases. We already discussed it, right? So if the object is placed on the inclined surface, let's suppose, so this is a object which is placed on the inclined surface like this. So let this angle be theta. So now this will have two components. What are the two components? This mg, downside it acts. So then this side one component, and then this side one component. So along here, so this is mg sin theta, and here this is going to be mg cos theta, right? So now the normal is going to be here. The surfaces are in contact here, so that's why the normal force is perpendicular to the point of contact. So in this particular case, so the normal is equals to mg cos theta. The normal is equals to mg cos theta. Understanding? Clear, guys? The basic things. So the friction, basically it depends on two things. So what are they? So one, friction is directly proportional to the roughness of the surface, which is nothing but coefficient of friction. And friction, it is also directly proportional to the normal reaction. So it is also directly proportional to the normal reaction. So on these two factors, so the frictional force will depend. Done? Basics. Chalo. So let's move further. So now there are two types of friction. So one is the static friction, when the next one is the kinetic friction. So the static friction acts when object is in rest, or when body is in rest. When object is in rest, so then the friction acts on that body is said to be static friction. See here. So this is the rough surface. We place the object of mass m here. So this object of mass m, it is at rest. It is at rest. Okay. So now let's suppose it is tending. It's tending to move. It's not moving. It's tending to move. So in that case, still it is in rest now. So in that case, the friction that acts is the Fs, the static friction, which is Fs we call. Okay. So for the static friction, there is no formula for the static friction. For the static friction, so you'll understand all these things as the class progresses further. Just understand the basics one by one. Okay. So here there is no formula for the static friction. Static friction is a variable friction. So here I'll write. So the static friction is variable. How it varies, we'll see in today's lecture itself. Okay. So then kinetic friction. So the kinetic friction acts on the body when the object is in motion. When the object is in motion, so then the force that the frictional force that acts is a kinetic friction. Let's suppose this is a rough surface. Okay. So now you applied the force F on this body, so that the body is accelerating to the right. Consider the body is accelerating to the right. So as the body moves towards the right, so then the friction force that acts to the left is a kinetic friction, which we call it as Fk. The kinetic friction, this is Fk. So where the kinetic friction will have the formula. So the kinetic friction will have the formula, which is mu k into n. Mu k into n. So this is the formula for the kinetic friction. This is the direct formula. But for the static friction, there is no direct formula. So its value is variable. So what is mu k, sir? Mu k is the coefficient of kinetic friction. There are two types of coefficient of friction. As see, mu is the coefficient of friction, right? So there are two types of coefficients of frictions now. So what are they? So one is mu s. If I say this is coefficient of static friction, this is coefficient of static friction, and then mu k is a coefficient of kinetic friction. Mu k is a coefficient of kinetic friction. Remember these two. So, and one more important point here is always the static friction, the coefficient of static friction will be greater than the coefficient of kinetic friction. The coefficient of static friction will be greater than the coefficient of kinetic friction. So just understand in simple words how it is possible, sir, like how it is. See, if a body is at rest, so to move that body, to make that body in motion, so we have to apply the large force. Yes or no? Once the body comes to the motion, so then you need not to be applied more force, right? To move it initially, you need more force. Once it starts moves, you can apply the less force. The coefficient of static friction is that one only, right? It will be more. If the coefficient of static friction is more, so that's why you are unable to move the object easily initially. Once it starts moving, you can apply the less force. That means the coefficient of kinetic friction is less. Okay, so this point is very, very important. Note it down. Clear? There are two types of coefficients of friction, static and kinetic. And there are two types of friction, static friction, kinetic friction. Static friction, there is no direct formula. For the kinetic friction, direct formula Fk is equals to mu k n. So static friction acts when the body is in rest. Okay, it is tending to move, but it's not moving actually. So when the body is in already motion, and the friction which opposes that relative motion is a kinetic friction. Clear this part also? Sure. So let's move further. So in the kinetic friction also, we can say that there are two types of friction again. One is sliding friction. When you move when you push the object, so it slides on the floor. Let's suppose it slides on the rough floor. So then it is said to be the sliding friction. So if it rolls, let's suppose there are wheels for this. So if you push it, so it's rolling, right? So this is called rolling friction. Okay. So sliding friction and rolling friction. So in these two, where the friction will be more? Tell me. The sliding friction will be greater than the rolling friction. So to slide, you need more force. To roll, if the wheels are there, you can easily move it, right? So that means, so the sliding friction, rolling friction are two types of the kinetic friction. So, and in these two, which is more? The sliding friction will be more than the rolling friction. Clear? The simple one. Done, guys? Chal, next. So the question, so pause the video and try it on your own. So try the questions on your own, guys. A block B is pushed momentarily along a horizontal surface with an initial velocity v. So if mu is the coefficient of sliding friction between B and the surface, so here is a coefficient of friction, sliding friction. So and block B will come to rest after a time. See here. So let's analyze the situation first. So here is a block surface, rough surface, and this is a block of B. So then you applied some force, so then it starts moving. See here, the block B is pushed momentarily along a horizontal surface with an initial velocity V. So it's moving. So then it moves till some time, and then it comes to rest. It comes to rest. So whose velocity will become 0 after some time. So if mu is the coefficient of sliding friction, so as the object is moving to the right, obviously which friction comes to the role? The kinetic friction. The first concept that you should understand is what kind of friction is acting on the body here. So that is the kinetic friction, because the body is in motion, right? So and then, so obviously the given coefficient of friction, let it be mu, right? So I can say that, let's find its acceleration. Here there is a contact force. Here there is a contact force. So I can say this is of normal n. So and this is block is of mass m. Let's consider its mass is given. So let's take the block of B has mass m, so that its weight mg will act downward. Yes or no? So therefore here n is equals to mg. Let's understand carefully. N is equals to mg. So now what is the kinetic friction? Kinetic friction formula is equals to mu k into n, right? So here mu k it is given as mu, so n it is mg, right? This is the kinetic friction. So now shall I find the acceleration of the body? Shall I find the acceleration of the body? So how do you find the acceleration? The acceleration is equals to force upon mass. So what is the force acting on the body? So which is nothing but the kinetic friction. So the kinetic friction acting on the body is mu mg by, so the mass of the body m. So m cancel. So the acceleration of the body is mu g. So this acceleration is acting in which direction? So the acceleration due to the friction is in this direction. Yes or no? Body is moving to the right, but it is retarding, right? It's coming to rest means it's retarding. The retarding means the acceleration is opposite to the motion. Understanding? Chalo. So now A is equals to mu g we got. So and see, shall we use the kinematic equations? So I got the initial velocity of the body is equals to v, and final velocity is equals to 0. The acceleration is equals to mu g, or else you can take minus mu g, your wish. Okay, so then, so let me write v is equals to u plus at kinematic equation. V is equals to u plus at. So from here, so what we need time, right? So v is 0, u is v. In place of u, the initial velocity v. So in place of a, I am writing minus mu g. In place of a, I am writing minus mu g, because the acceleration is negative side, right, into t. So we need time. So t is equals to here v by mu g. T is equals to v by mu g. G mu by v. So g by v, v by g, v by g mu. Option D is a correct one. Clear, guys? Simple question again. Done? Chal. So let's move further. Next one. So the question number 2. So what's the question says here? A conveyor belt is moving at a constant speed of 2 meters per second. A box is gently dropped on it. The coefficient of friction between them is mu 0.5. The distance that the box will move relative to the belt before coming to rest on it. See here. So this is a conveyor belt. So consider this is a conveyor belt. So this is a conveyor belt. So on this conveyor belt, see here. So a box is dropped. This conveyor belt is moving at a speed of 2 meters per second. Let's suppose it is rotating this way. The conveyor belt, see here. So now a box is gently dropped on it. So here a box is dropped on it. So the coefficient of friction between the so belt and the block, so here the coefficient of friction is given 0.5. Fine. So the distance that the box will move relative to the belt before coming to rest. So before coming to rest, it's moving like this, so that the box will move to the left. The box moves to the left, right? So with what speed the box moves to the left? So I can say the u is equals to 2 meter per second. With whatever the velocity the conveyor belt is moving, so with the same speed the box moves, and after sometimes it's come to rest. So its initial velocity is 2 meter per second, and then its final velocity is 0. So we have to find how much distance it is traveling before coming to the rest. So let's find the acceleration here. How do you find the acceleration? The acceleration is equals to force upon mass. So what kind of force acts on the body here? The friction force. Yes or no? So as the object moves to this side, so the friction force acts to the right. Yes or no? What kind of friction? As the object is in motion, so the kinetic friction. Just understand the basic logics. So by mass m, so we can say that the coefficient of friction is mu into, so its mass is m if you say, so then in place of n you can write mu n by m. Yes or no? So from here mu into, in place of n we can write mg. The n is equals to mg here. So in place of n you can write mg. So then here also the acceleration is simply mu g. So we got the acceleration is equals to mu g. You know u, you know v, and you know a. So shall we find what is the distance? Simply let's use v square minus u square is equals to 2as. So from here I can write v square. What is v? 0 square minus u square, so which is 2 square 4, which is equals to 2 into the acceleration, which is mu into g into the s, right? So from here this is going to be minus 4, so 2 into, so mu value, what is mu value? 0.5. so g value they said let's take it as 10, so into s. So this comes out to be minus 4 is equals to, this is 5 into 2 10 into, so this one, so s is equals to 0.4 meters. So this minus indicates to the left, so the s is equals to 0.4 meters. Clear? Understood? Chalo. Let's move further. The next question, question number 3. A block of mass 10 kg is placed on a rough horizontal surface having coefficient of friction mu 0.5. If the horizontal force 100 newtons is applied on it, then the acceleration of the block will be, see here. So this is the block surface, and here is a 10 kg block which is placed on the 10 kg block. So 100 newtons force is acted, let's suppose this side, right? So and the coefficient of friction mu is given here, so this is 0.5. So they are saying find the acceleration of the block. See here, first what is the friction that comes into the role? This side the friction will act as the object is moving. So what kind of friction will act? The kinetic friction. So let's find what is kinetic friction first. So the Fk is equals to mu into n. Mu k means here mu is given, directly consider it as kinetic friction. If nothing is given, consider that as a kinetic coefficient of kinetic friction, right? So mu 0.5. So here n is equals to, we can write mg. N is equals to here simply mg. So yes or no? Normal is upside and body's weight mg is downside, right? N is equals to mg. So m is 10, g is 10. G they said take it as 10. So this is a friction. So 50 newtons. So the, see here. So this is a 50 newtons. So let's draw the free body diagram of this. So if you consider this is a 10 kg block. So on this 10 kg block, 100 newtons is acting right side and the frictional force 50 newtons is acting left side. Obviously the body accelerates to the right. Yes or no? Obviously the body accelerates to the right. So then you can find the acceleration easily. How do we find? So the Newton's second law. So more force minus less force is the net force, which is equals to mass of the body 10 kg into its acceleration a. So that's why it's going to be 50 is equals to 10 into a. From here the acceleration a is equals to 5 meter per second square. So the acceleration A is equals to 5 meter per second square. Clear? Option C is the correct one. Done, guys. So let's move further. So the question number 4. See, let's understand the concepts through the questions so that you can understand easily. A block of mass M, a block A of mass M rests on a horizontal table. A light string is connected to it, passes over a frictionless pulley at the edge of the table, and from its another end, another block of mass M2 is suspended. So the coefficient of kinetic friction between the block and the table is 𝜇k. So when the block A is sliding on the table, the tension on the string is, see here. So first understand the question. A block of A of mass M1 rests on a horizontal table. Consider this as a horizontal table. So here the block of mass M1, this is a block A which is of mass M1. So then a light string is connected to it and passes over a frictionless pulley. So here is a frictionless pulley at the end of the table. So and then a string is connected, and then see here. So from its another end, so block of mass M2 is suspended. Here this is a block B whose mass is M2. So this is a diagram given. Clear? So then the coefficient of kinetic, this is a rough surface. This horizontal surface is given as rough surface. So previously we solved the pulley questions where there is no friction, right? So here this mass M1 is placed on a rough horizontal surface. So what is the coefficient of kinetic friction? 𝜇k is given here, right? So then the tension in the string. So the first thing is here the tension T, here the tension T. So and here the tension T away, right? So what they are saying, when the block A is sliding on the table, when the block A is sliding means the block A is accelerating to the right. So block B is accelerating this side obviously. So let's consider according to the question M2 is greater than M1, so that it slides downward. So it slides right side. Yes or no? So as the body is sliding to the right here, so here the kinetic friction comes into the role. The kinetic friction that acts is Fk left side. Yes or no? So now see here, let's write the equations for these two blocks. So for this block, for the first for the A block, let's write for the A block. So for the A block I can say that the tension is more. Yes or no? The tension is more because the acceleration is this side. Minus Fk is equals to M1 body into its acceleration A. Yes or no? Tension is more, that's why acceleration is this side. So T minus Fk is equals to M1 into A. So what is Fk? The coefficient of kinetic friction is equals to 𝜇k into N. So what is the N here? See, the contact force is here. Don't get confused, just try to understand the concept here, guys. So here the normal force acts upside, and then its weight m1g downside. Its weight m1g downside. So therefore the kinetic friction is equals to 𝜇k into, in place of N, so just simply write m1g, right? So that's why I am writing for the block A, it's going to be T minus 𝜇k m1g, 𝜇k m1g, which is equals to m1a. So let it be equation number 1. So now write for the block B. For the block B, see here the acceleration is downside. That's why obviously the weight is more, m2g is more than the tension. So m2g minus T is equals to, so it's mass into acceleration. It's mass into the acceleration. So let it be the equation number 2. So see here in the given question they are saying find the tension in the string. See, if you subtract, if you add these two equations, the tension gets cancelled. Don't do that. Here maths plays the role. So let's divide 1 by 2. Let's divide equation 1 by 2. So what is the equation 1 we have got? So T minus 𝜇k m1g, 𝜇k m1g is equals to m1a, right? By, so what's the second equation? m2g minus t is equals to m2g minus t is equals to m2a, right? So we are dividing these two equations. So here acceleration cancels. So we need the tension, right? So let's cross multiply. So m2 into, so do the calculations properly. So mu k m1g is equals to m1 into m2g minus t, right? So from here, so let's write this one. So m2t minus mu k m1 m2g is equals to m1 m2g minus m1t. Let's bring the t terms to one side. So here if I bring this to this side, so the m1t plus m2t is equals to, I'm bringing it to this side, m1t plus m2t is equals to, send this to that side, m1 m2g, this becomes plus. So mu k m1 m2g, right? So from here, so we need the tension T, right? So here T, take it common, here m1 plus m2 will come, so which is equals to, so let me take m1 plus m1 m2g common, so that here 1 plus mu k will come, 1 plus mu k, yes or no? So then next, so next see here, so we need the tension T. So the tension T is equals to m1 m2g into 1 plus mu k by so m1 plus m2, m1 plus m2. So see this option, they are asking the tension, right? m1 m2 plus mu k m1g, yeah? m2 plus mu k m1g, no, so the option 1 is wrong. m2 minus mu k m1g, m2 minus mu k m1g, no, so second option is also wrong. So m1 m2 into 1 plus mu k g, m1 m2 into 1 plus mu k g, yes, we can take this one. So and then the denominator m1 plus m2, correct? So here m1 m2 minus is there, so no. So m1 m2g into 1 plus mu k by m1 plus m2, option C is the correct one, guys. Clear? Done? Sure. So next, so let's move further. So let's take the next question. What's the question says here? A system consists of three masses m1, m2, m3, m1, m2, m3. So connected by a string passes over a pulley. The mass m1 hangs freely and m2, m3 are on the rough surface. m1 freely hanging, m2, m3 are the rough surface. This is a rough surface given. Fine. So now, so the coefficient of friction here it is, mu is the coefficient of friction. So then, so the pulley is frictionless and negligible mass. So the downward acceleration of mass m1. See the simple concept. Obviously here its acceleration will be this side and its acceleration will be this side and its acceleration will be this side. So and in the previous classes, to find the net acceleration we have seen what is a simple formula. So the net force by net mass, here the net force by net mass. The simple concept is net force by it's a net mass. So which is nothing but here the force that is acting is m1g. Here the force that is acting is m1g, right? So and as it slides to the this side acceleration, so here the friction force acts this side and here the friction force acts this side. So they said all three masses are equal. They see here. So assume m1 is equals to m2 is equals to m3 is equals to m, right? All three masses are equal. So this is of mass m, this is of mass m, this is also of mass m, right? So that's why, so the net force will be acceleration is equals to, shall I say, mg minus, so here what is the friction force that acts? Tell me, what is the friction force that acts? So mu n means mu mg. And here also what is the friction force that acts on this? Again mu mg. So therefore, so mg minus 2 mu mg, shall I write? It is the net force. Yes or no? The m1g, which is nothing but m1 is equals to m, right? So that's why I'm writing mg minus, so these here the friction force this side, here also the friction force to the right. So this is mu mg, this is mu mg. So mg minus 2 mu mg by so what is the total mass? M plus m plus m, so which is 3m. So you can cancel m. So simply the acceleration is equals to, so you can take g common in the numerator, 1 minus 2 mu by 3. So g into 1 minus 2 mu by 9, no, this is no, g into 1 minus 2 mu by 3. Option C is the correct one. Clear guys? Understood the concept? Chalo. Let's move for the next question. So what's the next question says? So a wooden block of mass m resting on a rough horizontal table, coefficient of friction mu, fine. So then is pulled by a force F as shown in the figure. So the acceleration of the block moving horizontally is, see here, first thing is the force that is acting here is this one, right? So whenever the force is like that, you just draw the components of the force. So this side the F cos theta component will come, and this side the F sin theta component will come. The F sin theta component will come, right? And then here the normal reaction, that is N. So and the coefficient of friction mu, right? So and its weight mg will act downward. Its weight mg will act downward. So are there any other forces? So we have to find the acceleration, right? Chal. So first consider the summation of forces in the x direction is equals to 0, the horizontal equilibrium. Consider the horizontally it is accelerating, right? So a wooden block of mass m resting on a horizontal table, so is pulled by a force F. Okay, it is pulled by a force F. So the acceleration of the block. So okay, fine. See here. So let me write, shall I say n plus F sin theta is equals to mg here. This is vertical equilibrium. N plus F sin theta is equals to mg. Yes or no? So and what is the force that acts on the body? The friction force acts this side. What kind of friction? The body moves to the right, so that the kinetic friction comes into the role. So that's why I am writing, see, draw the free body diagram. So the horizontal force is F cos theta, right? And the friction force is Fk to the right. So body is accelerating. The acceleration of the block moving horizontally. The acceleration is right side, their side. So then shall we write the equation? So here for this, F cos theta minus Fk is equals to the mass of the block into the acceleration. Newton's second law I am applying, right? So from here, F cos theta minus what is Fk? So we know that mu into n, right? Mu into n. So then which is equals to ma, So from here, so let's do one thing. So we need answer in terms of mu only, right? So F cos theta minus mu into, so in place of n, so let me write this one. So in place of n, let's write n is equals to mg minus F sin theta. Mu into mg minus F sin theta, right? So which is equals to the acceleration which is equals to ma. See, I'm just going by the procedure, that's it. So first we have seen what is vertical equilibrium. N plus F sin theta is equals to mg. From there n is equals to mg minus F sin theta. This is fine. So now horizontally the block is accelerating right side. So that's why, so F cos theta and a that side, and the frictional force is acting opposite direction. So apply Newton's second law here. F cos theta minus Fk is equals to ma. So from here F cos theta minus, so the kinetic friction formula mu n is equals to ma. So F cos theta is equals to, what is n here? N is just not equals to mg in this case. So there is some other force is acting along with the n. So the n is equals to mg minus F sin theta here. Okay. So from here, this is F cos theta. So let's multiply it inside. So minus mu mg plus mu F sin theta which is equals to ma. Okay. So now let's write this equation in the next slide. So let's write it in the next slide. See here. So we have got, what's the equation that we got here? F cos theta minus mu mg, F cos theta minus mu mg plus mu f sin theta, right? Mu f sin theta is equals to ma. Mu f sin theta is equals to ma. So chalo, so let's do one thing. In these two terms, let's take f common. So this term and this term, I'm taking f common. So if I take f common, so this is going to be cos theta plus mu sin theta. Cos theta plus mu sin theta. So here minus mu mg, which is equals to ma. So from here, the acceleration a is equals to, so f cos theta plus mu sin theta by m minus mu mg by m by mu mg by m. So then m gets cancelled. So here I can write the acceleration is equals to f by m. Let's write simply f by m. So cos theta plus mu sin theta minus mu g. Minus mu g. So this is a complete acceleration of the block. So I could see the only option is this one, option C, right? F by m cos theta plus mu sin theta minus mu g. Understood, guys, the concept? Sure. So let's move further. So next, let's come to the slide, static friction. See, as we discussed earlier, the static friction, there is no direct formula. So there is no direct formula for the static friction. So the static friction is a variable friction. It's a variable friction. So from where to where it varies, sir? See, now understand. So there is something called as limiting friction. So there is something called as limiting friction. Limiting friction is the maximum friction value. So the limiting friction is equals to mu s into n. I'll make you understand the complete static friction and kinetic friction. So don't worry, I'm going to solve the questions now. So from which you can understand the static friction, kinetic friction very easily. Okay, first understand the theory, then we'll go for the questions. Okay, so the static friction always lies between, this is a Fs, which lies between, so the kinetic, 0 and the limiting friction. Its maximum value is limiting friction and its minimum value is 0. Okay, it always lies between that. So and then the static friction acts on the body when it is at rest and has a tendency of relative motion. So when the body is at rest and has a tendency of relative motion, then the static friction comes. That point we know. The maximum value of the static friction is equals to limiting friction. See here put like this. So the maximum value of the static friction is limiting friction. So the static friction's maximum value Fs is equals to the maximum is equals to the limiting friction. So what is the limiting friction formula? Which is equals to mu s into n. Mu s into n is the limiting friction. So the static friction is self-adjustable. So from where to where? 0 to limiting friction. 0 to limiting friction. And then there is no formula for the static friction as we discussed earlier. So this is just the theory. Now let's understand this concept by the questions. See, so what does it mean by varying, sir? We did not understand this point. So let's see it by the questions. Don't worry, just be with me for next 20 minutes or 30 minutes. So you'll understand everything. So NEET 2018 question. What's the question says? So which one of the following statement is incorrect? Rolling friction is smaller than the sliding friction. Obviously, this is correct. Yes or no? This statement is correct. The rolling friction is smaller than the sliding friction. Sliding friction is more, rolling friction is less, right? And then limiting value of the static friction is directly proportional to normal reaction. So the limiting value of the static friction. So we know that the static friction the FL is equals to mu s into n. So the limiting value of the static friction is directly proportional to normal reaction. Fine. And then frictional force opposes the relative motion. So this is second statement is correct, and the third statement is correct. So the coefficient of sliding friction has dimensions of length. See here. So what are the dimensions of coefficient of friction first? What are the dimensions? See. So let me take the kinetic friction formula. Fk is equals to mu k into n, right? So from here, mu k is equals to Fk by n. Yes or no? So the frictional force is a force. Normal reaction is also a force. Frictional force is a force, right? Normal reaction is also force. So both the units gets cancelled. There are no units for that. So if there are no units, so the coefficient of friction, it's a dimensionless quantity. The coefficient of friction, it's a dimensionless quantity. Remember this. The coefficient of friction is a dimensionless quantity. Clear? So you can write here also where we discuss the coefficient of friction. So here mu is a dimensionless quantity. Mu is a dimensionless quantity. Clear, guys? Sure. So let's move for the questions now. So which question we solve now? So the theory question, this one, right? So this question, easy question which was asked in NEET 2018. So now next, let's go for the question. So from here you understand carefully. Calculate limiting value of the friction. So the first question, A question. So calculate limiting value of the friction. What is the limiting value formula? Limiting friction has a formula which is mu s into n. So sir, kinetic friction is equals to mu k into n. So then mu s into n is equals to static friction. No. Limiting friction formula is mu s into n. So what is the mu s according to the given question? 0.6. 0.6 into normal. What is the normal here? So the normal reaction acts this side and its weight mg downside. So the normal here is equals to simply mg. So where the normal is equals to mass is 4, g is, let's take it as 10. So that's why it's going to be 40 newtons is a normal. So I'm writing 40 here. So which is going to be 24 newtons is a limiting friction. See, the limiting friction opposes the body's motion, right? See here. The limiting friction, here the force is acting. So the body is tend to move. So how much is the limiting friction? So the limiting friction is 24 newtons. So the first question is done. Now coming to the what is the friction force? The B question, here you understand carefully. So the B question, what is the friction force? See, on the body 20 newtons is acting, right? And the limiting friction is 24 newtons. The limiting friction is 24 newtons. So if you place the object on a horizontal surface and you are applying the 20 newtons force, the object is not moving. The object is not moving, right? So but here it says that if you see this one, 24 newtons this side, 20 newtons this side, which means the object moves to the left. Which means the object moves to the left. So have you ever observed when the object is placed on the horizontal surface and you applied some force, that force is not enough to move that body. So will it move to the opposite side? No, right? It will not move to the opposite side. So here the limiting friction, this is a maximum value of the friction. The limiting friction is a maximum value of the static friction. So now how the static friction is adjustable means the static friction adjusts itself to the applied force. If so the F limiting is greater than the F applied, if F limiting is greater than the, let me write here. So the B question, so let me do it here. So if F limiting is greater than the F applied, which means if you place an object at rest on a horizontal surface and you are applying the 20 newtons force, that force is not enough to move that object, fine. So it will stay in rest. but it will not move backward, right? According to this 24 Newton this side means it should move backward, which is not possible. So then what's the phenomena happening here? The friction, the static friction adjusts itself to the applied force. So if the F limiting is greater than F applied, so then what happens? So the static friction Fs adjustable. So it adjusts itself to the applied force. So that's why the static friction in this case will be equals to, what is the friction that is acting here? The body is not moving here. So that's why the static friction I am saying. So what is that static friction? It adjusts itself to the 20 newtons. So that's why it's the static friction here acts is a 20 newtons. So this is a maximum value. It adjusts up to 24 newtons. If you apply more than 24 newtons this side, so then the object moves up to 24 newtons. So the body static friction adjusts itself to the applied force. Let's suppose you applied the 21 newtons here, consider. So then the static friction becomes 21. If you applied the 22 newtons, the static friction adjusts itself to the 22. So if you apply 23 newtons, the static friction adjusts itself to the 23. If you apply 24, so it adjusts itself to the 24. If you apply 25, then the object starts accelerating to the right, because the maximum value is 24 only. You are applying the 25, so then it moves to the right. Then kinetic friction comes into the role. Understanding when the static friction and when the kinetic friction? Okay, chalo. So here the static friction itself, it adjusts itself to the 20 newtons. This is a B question. And what is the acceleration of the block? So the C question, so the acceleration is going to be 0, because 20 newtons this side, 20 newtons that side. So there is no acceleration. Done? Clear, guys? Chalo. So if you don't understand this one, chalo. So we'll solve one more question, you'll understand better. So 9th question, what's the question says here? See, so here is a wall and you are applying the force. This is the object of 0.1 kg. So and then you are applying the force, 5 newtons force on the, that means you are pressing or forcing the object against the wall. Okay, so then what is the limiting value? Friction, force, acceleration. So first thing is, its weight acts downward. What is its weight? What is its weight? So the weight mg is equals to 0.1 into 10, which is nothing but 1 Newton is its weight. Yes or no? So now most of the students commit mistake in this question is that they take the normal this side. So normal is the contact force, right? Normal is the contact force. Here is the contact, right? So the normal force act which side now? This is normal reaction. This is a normal reaction. Yes or no? So the normal reaction is equals to, shall I say simply 5 newtons? Because 5 newtons you are acting this side. So the normal which is this side. So the normal is balanced by the 5 newtons. So friction acts in the which direction? The friction acts in this direction. The friction acts in this direction. This logic you should understand. Its weight is 1 Newton. And then, so the normal reaction is this side. So and then 5 newtons is that side. That's why normal is equals to 5 here. And the friction acts upside. Yes or no? So the body slides downward or tends to slides downward. So obviously the friction acts upside. So now the first question, see here, what is the limiting friction value? So the F limiting is equals to, we have got the formula mu s into n. So what is mu s here? Mu s is 0.5. N is equals to, don't take 1 Newton is the n. N is equals to mg. No. Here n is equals to directly 5. So which is nothing but 2.5 newtons. 2.5 newtons is the F limiting. So that means the limiting friction 2.5 newtons is acting upward. This is the maximum value of the friction. This is the maximum value of the friction which is acting upward, 2.5 newtons. Yes or no? So then what is the weight? 1 Newton. What is the weight? 1 Newton. So weight is 1 Newton. 2.5 newtons is acting upwards. So if you are pressing the object against the wall, is there any possibility to move it up? You are just directly pressing it against the wall. So either it should slide downward or it should stay in rest. So but it will not move upward, right? According to this, it says that 2.5 is more, it should move upward, which is not possible. So what's the concept here? The limiting friction, the static friction adjusts itself to its weight, 1 Newton. So the second question, the B question, here F limiting is greater than F applied. Yes or no? F limiting will be greater than F applied. So therefore the static friction Fs, so it adjusts itself to the applied force. Here applied force means don't take the 5 newtons. So its weight, it adjusts itself to the weight. So it's therefore the static friction is 1 newtons here. So and then option C, the question C, acceleration here 1 Newton upside, 1 Newton downside. So acceleration 0. Clear? Understood, guys? Chalo, so let's move further. So let's take one more question here. So again same concept. What's the question says? See, the 20 newtons force is acting right side. So first question is find the F limiting. So the F limiting formula, which is equals to mu s into n, right? So what is mu s? According to the question, mu s is given 0.6 into, so what is n? This is the normal and this is the weight mg here. So n is equals to mg. So mass is 2 kg, g value let's take it as 10. So the normal reaction is 20. So that's why this is going to be 12 newtons is the F limiting. So F limiting is acting which side? The limiting force should oppose this side because the force is that side. So the friction force will be this side. What is the F limiting? The F limiting is equals to 12 newtons. So now come to the second question. See, the F applied is 20 newtons and F limiting is 12 newtons. So the maximum force of the static friction is 12 newtons only. So that's why the F applied here is greater than F limiting. Yes. So the object starts moving. So if the object is if the object starts moving, so then which friction comes into the role? The kinetic friction comes into the role. Yes or no? Understand the concept. Here the object is moving. Means which friction comes into the role? The kinetic friction. So what is the kinetic friction value? So the Fk is equals to mu k into n. So mu k value. So take the mu k value 0.4. Normal. What is the normal reaction? 20. So this is going to be 8 newtons is the friction force. What friction is acting? So the kinetic friction, because the applied force is more than the limiting force. So that's why the kinetic friction comes into the role. So now come to the question C. What is the acceleration of the block? Draw the free body diagram. So 20 newtons force is right side and then 12 newtons force is left side and then the acceleration is right side. Yes or no? More force is right side, that's why acceleration is right side. Apply the Newton's second law. So more force minus less force, 20 minus 12 is equals to mass of the body into the acceleration. So here 20 minus 12, 8 is equals to 2 into A. So from here A is equals to 8 by 2, 4 meter per second square. So acceleration is equals to 4 meter per second square. Clear? Understood the concept, guys? Chalo. So let's move further. So next question, you try to solve this question on your own. Same 9th question type. So the first one, find the F limiting. So F limiting formula is mu s into n. See here, again the same thing here. The friction acts this side. Yes or no? So and its own weight. What is the weight? 5g. 5 into g, which is nothing but 50 newtons. 50 newtons. So this is the rough surface. So here the thing is normal is this side. Yes or no? Perpendicular to the point of contact. So normal is equals to what? 100 newtons here. So the normal is equals to 100 here. Don't take normal is equals to 50. Normal is this side and 100 newtons that side. That's why normal is equals to 100 here. So mu s is what? 0.4 into, so n is 100. So that's it. This is 40 newtons is a F limiting. So this 40 newtons force is acting which side? So this F limiting 40 newtons is acting upside. Now see the diagram. The applied force, here its weight is the applied force. Yes or no? It's due to its weight, it should come down. 50 newtons is acting downside. So 40 newtons is upside. So that's why in the second question, in this kind of questions, its weight is greater than the F limiting. Its weight is greater than F limiting. So then object slides down. The object slides downwards. The object slides downwards. So whenever the object is sliding downward, so what kind of friction comes into the role? The kinetic friction. Yes or no? So the kinetic friction comes to the role. So what is the kinetic friction formula? So the Fk is equals to mu k into n. So what is the mu k value? So the mu k value is given as 0.3. So into what is normal? So the normal is equals to 100 here. Normal is equals to 100. So that's why this is 30 newtons. So this is a 30 newtons is a frictional force, the kinetic friction. So now let's find the acceleration of the block. So the C, acceleration of the block. Draw the free body diagram. So here the kinetic friction 30 newtons acting upward, and then its own weight 50 newtons acting downward. So that's why its acceleration will be downward. So what is that acceleration? So that acceleration is equals to 50 minus 30 by its mass 5. So which is nothing but 20 by 5. So which is 4 meter per second square. So it slides downward with an acceleration of 4 meter per second square. Clear? Understood, guys? Chal. Next. So let's move further. So the next question. So what's the question says? What is the maximum value of the force F such that the block shown in the arrangement does not move? This block should not move. Okay. So first, what is the force here? Extend this force. Whenever the force is this way, so extend this force. So I can say that if it is 60, this is also going to be 60 degrees. Yes or no? So if this is 60 degrees, so this angle is also going to be 60 degrees. So then draw the components of force. What are the two components of force? So this side, the F cos 60, and this side F sin 60. So the object does not move, they are saying. So if the object does not move, so then the summation of forces in the x direction should be 0, and the summation of forces in the y direction should be 0. That's it. Yes or no? So and as the object, the coefficient of friction is given, mu is given 1 by 2 root 3. So obviously the friction force is acting right side. The horizontal force is responsible for the motion, right? So that's why the friction which acts here, this side, the friction acts. Okay. So then the summation of forces in the x direction, so is 0. Summation of forces in the y direction. What are the forces in the y direction? So the normal reaction acts upside, right? So let's do one thing. Normal is upside, and its normal is equals to F sin 60 degrees plus its own weight. So what is its own weight? Root 3g. What we have to find actually? What is the force F? Yes, okay, fine. So then here n is equals to, what is F sin 60? Sin 60 value is root 3 by 2. So that's why F into root 3 by 2 plus this is root 3g. Let it be in the vertical direction. So now let's take the horizontal direction. So what are the forces that are there in the horizontal direction? So the F cos 60, the F cos 60 must be equals to, so the friction, what is this friction? Let it be Fk. So from here I can write, so F cos 60 is nothing but F by 2. So this is equals to, so mu k into n. What is the mu? Mu into n, let's write. So then F by 2 is equals to mu into, so in place of n, let's write this one, F root 3 by 2 plus root 3 g, right? So from here I can do, so we need just the force, right? So just do one thing, we need just the force value. So yes or no, f, this is for f sine 60 only, right? So sine 60 means n is equals to f sine 60 root 3g, fine. So n is equals to f root 3 by 2, so which is equals plus root 3, fine. So here the cos 60, f cos 60 should be balanced by the this force, yes, fine. So fine, see here, so f by 2, so substitute the values. F by 2, what is the mu value here given? 1 by 2 root 3, 1 by 2 root 3, so which is f root 3 by 2 plus root 3g. So I can take root 3 common and cancel root 3, root 3, root 3, right? So from here, let's do further. So we can get f by 2 is equals to, so here 1 by 2 into f by 2 plus g. So here 2 cancel. So f is equals to f by 2 minus, sorry, plus g. So here f minus f by 2, so which is f by 2 is equals to g. So then f is equals to 2g, which is nothing but 20 newtons. So the f is equals to 20 newtons. Clear? Understood, guys? The concept is clear? Sure. So let's move further. So let's solve one more question. What's the question says here? The coefficient of static friction is μs between the block A of mass 2 kg and the table as shown in the figure is 0.2. So here the coefficient of friction is 0.2. So then what would be the maximum value of block B so that two blocks do not move? The string and the pulley are assumed to be smooth and massless. G, take it as 10 meter per second square. So let this mass be m. Let this mass be m. So here let the tension is equals to T. So the T is equals to, shall I say, mg. So the first thing is for the B block, T is equals to mg. So now for the A block is also in the rest. A block also should be in the rest. So here also the tension T, and this side the force that acts is a frictional force. So let this frictional force is a static friction or whatever it is. So that friction force is equals to mu into n. What is the normal here? N is equals to, so its weight. What is weight? mg. Yes or no? So mu into, in place of n we can write 2g. So or else simply write mg now. So now for the A block, so the T must be equals to the T, it is not moving, right? So two blocks do not move, they said, yes, fine. So the T must be equals to, so the frictional force. So here what is that frictional force? The T is equals to, the in place of frictional force you can write mu mg, right? So this is a mass of block A. Let's write mass of block B, that is. So let's substitute the values, don't worry, see here. So mu is what? 0.2. Mass of the block 2 into, this is, let's write mass of the block B, let's write mb. Okay, so 0.2 into 2 into g value 10. So this is 2 into 2, 4. So this is the tension. So then consider this equation now. So T is equals to mb into g. So what is T value we got? So T is equals to 4 we got. So mass of the block B is mb into g value is 10. So from here mb is equals to, so 4 by 10, which is nothing but 0.4 newtons. Sorry, mass, right? Kg. So 0.4 kg. Option A is the correct one, guys. Clear? Understood the concept? So that's it. This is about the first lecture of your friction. So where we covered what is friction first and what are the types of friction and the coefficients of friction. So the coefficient of static friction, coefficient of kinetic friction, and then we also studied the concept, different standard formulas, right? And we understood how the static friction is a self-adjustable friction. Understood? Clear? So with this I am winding up the today's lecture. So sit for next 10 minutes and write your own short notes, guys. That's very important. And solve some more questions. I already solved 13 questions in the class. So and you solve some more questions, take from any reference book or any DPP of physics or any physics Wallah or any practice sheet of physics Wallah. Okay, you can find n number of materials for free in the app also. Okay, so you can just solve some more questions on the friction to analyze your understanding levels, like whether you are able to apply the concept that you learned from this lesson or not. You just analyze yourself. So if you are not able to do those questions, so then your concepts are not good. So again go through the concepts once, so then again try solving those questions. So that's the way you should improve yourself. Okay, so you are the mentor to yourself, guys. So no one, like the best mentor for you is yourself, for anyone. Okay, so just try this method and we'll meet in the next session, that is tomorrow again with the friction concept. So till then, keep studying. All the very best, guys. Bye, take care.